In this video, we will see that how we can create and model the spiral reinforcement in the particular concrete column. So for that, currently we are in the point library mode and we have defined a concrete column with a height of 5 meters and the diameter is defined as 2.5 meters. We'll close this menu panel. So for that, for the modeling of the spiral reinforcement, we'll go to the model ribbon. Under the model ribbon, we are having an option called rebar. Under the drop-down of rebar, we'll find an option called spiral rebar option. We'll click over it. A menu panel shall appear. It is asking for selecting a member. So on which member we want to create spiral reinforcement, we have to define it. So currently we want to define the spiral reinforcement for this particular concrete column. We will select it using the mouse left click. Now under the select member option, we are having an option for longitudinal rebar. Either you want to create the longitudinal rebar along with the spiral reinforcement or you don't want to create it. So if you check on it, the longitudinal reinforcement section shall appear under the property tab. And if you check off it, the longitudinal property option won't appear in the property tab. So currently we are in the spiral reinforcements property. So before starting, let's go to back to the create option and let's check on this create option. Let's go back to the property option. You will find spiral and the longitudinal reinforcements over there. Now we can go with the basic properties of the spiral reinforcement. Under the classification, you can go for auto name or you can define your own naming as per your requirement. You can define the grade of the reinforcement. Apart from that, if you are having or following any specific rebar code, you can choose it from over here. If you don't find any specific rebar code for your region, you can simply go to the rebar drop-down menu and you can choose the specification option over there and you can define your own standard rebar specifications. You can choose the nominal diameter and the bending radius for the reinforcement. Apart from that, there is an option called cover thickness from start plane and from end plane cover thicknesses. And at the last, we are having a hook option. So let's talk about the hook option first. If you are having different start and end hook, this is the start of the spiral reinforcement and this is the end of the spiral reinforcement. If you are having same hook properties at both of these ends, you can check off this option. But if you are having different hook properties, let's say you are having 135-degree hook over here at the start location of spiral reinforcement and at the end you are having no hook or you are having any other hook properties. So you can check on this option where you will find start point and end point options. You can define and customize your hook profile as per your requirement. And if you don't want any hook at the end location or at the start location, you can just select the hook type as no hook. Now let's check off this option. Over here, we are dealing with the cover thickness option. So there are three options. One is on plane cover thickness and two options are for from start plane and from end plane cover thicknesses. So in CIM, basically, any member where you are going to model any particular type of reinforcement will have any start face and end face as well. So for this concrete column, the bottom face of this concrete column will be termed as the start face, or you can say the start plane, and the end of this concrete column will be named as end plane. So let's go to the drawing view which we have created for the reference. Over here we are having section view of column as well as the elevation view of column. So if we go to the section view, white reinforcements are representing the spiral reinforcement while the red circles are representing the longitudinal reinforcement. Same for the elevation view. The red ones are for the longitudinal reinforcements while the white ones are representing the spiral reinforcement. So in the section view, the distance between the center of the reinforcement, the spiral reinforcement, and the most outer concrete fiber will be termed as the cover thickness. In the CIM, it is termed as on-plane cover thickness. So currently we are modeling the reinforcement on this plane and the cover thickness will be the distance between the most concrete outer fiber to the center of the spiral reinforcement. On the same way, if you look in the elevation view, in our scenario, this is treated as the end plane, and this face is treated as the start plane of the concrete column member. So when the spiral is going to begin, from that point to the most extreme fiber location will be treated as the start plane cover thickness. So we are telling the program in the 3D member geometry, the reinforcement shall be start modeling after this much of cover, providing this much of cover thickness. Either it is for start or it is for end. We can define both of them. Now, if you look, the distance between the two consecutive spiral rings is known as the pitch. We can also define the pitch distance in the CIM. So we'll go back to CIM model. So first of all, let us go to the top view. Now let's define the cover thickness as 0.1 meter. So it got automatically updated. And if you go to the front view, from start plane cover thickness, so the cover thickness will be started from the center of this spiral reinforcement to the start plane location. So currently it is 0.1 meter. So let's change it to 0.5 meters. Similar way, this is the end plane of the concrete column, and we'll place the from end plane cover thickness as 0.75 meters. These are just for the examples. Now, under the spiral reinforcement, there is a second option called arrangement. If you go over there, you can find two options like pattern spacing and number and spacing. In the number and spacing, you can define how much number of spirals you want to be modeled in your concrete member. So currently, there will be only one spiral reinforcement. Now let's define 10 spiral reinforcement, 10 spacings at 0.3 meter distance. So it will create 10 spacing at 0.3 meter pitch distance. And if you want to go for the pattern spacing, so it will create spiral reinforcement throughout the member with a defined pattern spacing. Now let's go to the longitudinal rebar profile. If you click over it, the same properties are there. You can define the name and the grade and the specification as per your requirement. And you can go for the start and end hook locations if you want to provide any hook over there. Now let's talk about this offset distance.
Let's first understand that how CIM calculates the start length and the end length for the longitudinal reinforcements. So for that we are back to the drawing region, and over here if you remember, this is the end point location of our spiral reinforcement, and this is the start point location of our spiral reinforcement. So at that particular location, at that particular level in a 3D model, the program will calculate it as a base point from which the longitudinal reinforcement shall be modeled. So if you are providing, let's say, end length and offset length and the start offset length as 0 meters, so automatically the program will start modeling the longitudinal reinforcement from this particular level and end at this particular layer marked in the cyan color. And if you are providing any offset length, let's say in a positive direction or in a negative direction, automatically it creates the longitudinal reinforcement. It either shortens the length of the reinforcement or it extends the length of the reinforcement. So now let's go back to CIM. Over here, let's first assign the end length offset as 0 meter in the longitudinal rebar section. So you can clearly observe at the end point location, the program automatically creates a layer over that from which a longitudinal reinforcement can't be passed. But if you provide any offset distance, let's say in a negative direction, I am providing 0.25 meters, so it automatically expands, or you can say extend, the longitudinal reinforcement to 0.25 meters from the end location of spiral reinforcement. Same way, If you want to shorten the longitudinal reinforcement with respect to the start point or end point location of spiral reinforcement, you just need to assign the offset length as positive value. Let's say 0.5 meters. Apart from that, if you go to the arrangement option under the longitudinal rebar section, you can assign the number of rebars, how many number of rebars you want to model along with the spiral reinforcement. You can adjust it accordingly. So let's say I want 33 number of rebars in this particular column. So automatically it will calculate the spacing and will provide the number of reinforcements in the member. Now let's click on the green tick to apply the changes. So that is how we can create spiral reinforcement in CIM. We have gone through all the properties related to the spiral reinforcement as well as for the longitudinal reinforcement that can be modeled along with the spiral reinforcements.